So we're asked to draw a free body diagram showing a man wearing a parachute falling at terminal velocity. The first thing is you don't have to be an artist. You just need to draw a dot. And that is representative of the man wearing his parachute. You're then going to know that he has a gravitational force, so he's obviously being attracted to the earth, and that is Fg. That's not sufficient. You're going to have to actually write the word gravitational force. And then since he's got a parachute, he's obviously experiencing some air resistance. That air resistance will work against his motion. Now what's important is that if he is moving at terminal velocity, then you have to make these two arrows the same length, showing that they are exactly the same magnitude of force, balancing out to zero acceleration. The next thing you have to do is you have to draw a sketch velocity time graph showing a person falling out of a plane until they reach terminal velocity. So it has to be velocity and time. Time is measured in seconds. Velocity in meters per second. And then you are going to say, initially, the parachutist or anybody, a person, starts with a constant acceleration of 9,8 or 10 meters per second squared. As air resistance picks up, that parachutist or that person is going to fall faster and faster, but won't be getting as fast as fast. So in other words, the acceleration decreases. Now look what's happened here. I had a certain gradient, and in this case it will have been 9,8. And then slowly but surely my gradient has become less and less and less. That is showing a decreasing acceleration, because in a velocity time graph, the gradient is the acceleration. So initially, before the air resistance kicks in, there's a period where it's going at 9,8 meters per second, and then gradually gets less and less and less increase in the velocity. So the acceleration decreases until such time as the velocity stays constant. That constant velocity is terminal velocity. Over this section here, we've got decreasing acceleration. And over this section over here, we have constant. There's a constant gradient, so it's constant acceleration, and in this case 9,8 meters per second squared. Then it says draw a position or a displacement time graph to see what happens until they reach terminal velocity. Now the first thing that I need to do is displacement, and that is in meters. And time in seconds. The first thing is that we need to have an increasing velocity, and then we are ultimately going to have a constant velocity. So the constant velocity appears over there, and my increasing velocity is all the time this gradient gets steeper and steeper and steeper. That's looking terribly much like a straight line. Let's just try and make it a little bit clearer. So my getting steeper and steeper, and eventually is a straight line. So up till here, you have got an increasing velocity. And over here, you have got a constant velocity.